Hello everybody. Assalamualaikum warahmatullahi wabarakatuh. My name is ADLAN and me with my roommates today we're going to present our program-based learning in chemistry and we are from HK2. Okay, let's move on to trigger at a glance. So in 2019 there was a really tragedy event happened in Pasir Gudang which we call as Kim Kim River Pollution 2019. It is the toxic waste tragedy that affects the public. How? It is caused by surrounding factories in the industrial areas around the river in Pasir Gudang. So, how it is really started? In 2019, more than 5,000 people were affected by this toxic chemical pollution due to the illegal waste dumping at the Kim Kim River situated in Pasir Gudang. So it's basically affect many publics there, especially to children. So the spread of toxic fumes caused many symptoms such as respiratory issues, nausea, dizziness, and vomiting.
So, what is diffusion? Diffusion is the process by which molecules spread from areas of higher concentration to areas of lower concentration. In this case of polluted Kim Kim River, benzene, methane, and xylene are present in higher concentration in the water than the air. So before we're going to start, I'm going to tell you guys what is VOC. VOC stands for volatile organic compounds. These are organic chemicals that have a high vapor pressure at room temperature, which means they easily evaporate into the air. Commonly examples include benzene, xylene, and methane. VOCs can contribute to air pollution and have various health effects, making their monitoring and regulation important in environmental science. So for benzene and xylene, these are organic compounds that can easily evaporate due to their volatile nature. When the water in the river is disturbed by wind waves or temperature changes, these molecules gain energy and transition from liquid phase to a gas phase. They then move into the air where their concentration is low. Next, for the methane. Methane, this gas is lighter than air and can also escape into the atmosphere. It may come from decomposing organic matter in the river, where bacteria produce methane as a byproduct.
Thank you, Arif. So now I will be talking about the main sources of the pollutants that is affecting the Kim Kim River. Okay, so first up is benzene. So benzene is normally formed as a product of petrochemical production, which is where we crack larger hydrocarbon molecules, such as decane, as you can see on the right, into smaller hydrocarbon chains, including benzene ring. Okay, so why is benzene treated as waste? So basically, benzene, even if it's important, where it's used as one of the main compound in the production of polystyrene, if benzene is provided in excess, it would often be treated as waste and be discarded along with the other chemical waste from the factory. So for xylene is actually produced by making heavy hydrocarbons such as octane undergo dehydrogenation process, which is the removal of hydrogen atoms from its carbon chain. And xylene is actually important in the chemical industry. Only paraxylene is mostly used for production, while metaxylene or orthoxylene would be discarded as waste and would end up being thrown out into the environment. So the equation that you see below me is actually the oxidation of paraxylene to form terephthalate acid that will be processed further to form polyethylene terephthalate plastics.
Alright, now moving on. Next is methane. So where did methane comes from? So methane is mainly produced from the activity of the oil and gas fields done by the petrochemical factories. The composition of aquatic animals from the polluted waters can also cause dissolving of methane into water before quickly escaping as a gas form in high quantity. So the decomposition due to the anaerobic environment in the dead carcasses of aquatic animals, decomposing bacteria are forced to break down different types of molecules as food sources. Methanogenic bacteria, for example, convert acetic acid, hydrogen, and carbon dioxide into methane and water to produce energy. And these below are the equation for it.
Bismillahirrahmanirrahim. Assalamualaikum. My name is Iskandar Zulkarnain, and I will be continuing our PBL project with the physical and chemical properties of the chemicals involved. So we know the chemicals involved are benzene, methane, and xylene, and we also notice to each of those chemicals they have similar properties, and which also has a relation to their chemical bonds. So let me go to the first chemical, benzene. Benzene is a colorless liquid with sweet odor. It evaporates quickly, has quite a high boiling point, which is 80.1 degrees Celsius. It's insoluble in water due to its polarity being non-polar, and it's also a hydrocarbon, and it is highly flammable due to the fact that it reacts with oxygen easily. Next is methane, which is a colorless gas. It is also a hydrocarbon. It is slightly soluble in water and has a low boiling point of negative 161.5 degrees Celsius, which means that this chemical exists as a gas. And the methane gas can react with oxygen to form CO2 and H2. And lastly, for xylene, it is a colorless sweet smelling liquid, highly flammable, and it also has a high melting point of 130, of a range of 138 to 144 degrees Celsius. It is insoluble in water and is also highly flammable.
Assalamualaikum warahmatullahi wabarakatuh. My name is KASIH AMANI, and I will be presenting about the types of isomers that are given in our project-based learning. Okay, so for methane does not have any isomers, but it has a tetrahedral shape. And methane is actually naturally it is non-toxic, but when found in abundance especially in water bodies, it can cause oxygen depletion. Okay, so for benzene does not have any isomers also, but however, there are numerous derivatives due to the different types of substitutions that we can connect to its ring. So, benzene is a 6-carbon ring which is connected together by alternating double bonds. So these alternating double bonds give benzene its high stability, which causes it to easily interact with biological membranes and disrupt cellular processes. Benzene also has carcinogenic properties which can lead to diseases such as cancer. Benzene also affects bone marrow, and which this will lead to blood disorders. And in addition, benzene also forms reactive metabolites through enzymatic processes in our body. So this can be very harmful for us. So there are 5 different types of derivatives of benzene that I have drawn, which are benzyl, toluene, phenyl, phenol, and aniline. Okay, so last but not least is xylene. Xylene has 3 isomers, which are orthoxylene, metaxylene, and paraxylene. So xylene, which differentiates in where the second methyl group is attached to. So for orthoxylene, or also known as 1,2-dimethylbenzene, the second methyl group is attached to the second carbon, while metaxylene, or 1,3-dimethylbenzene, the second methyl group is attached to the third carbon. And last but not least, paraxylene, which the second methyl group is attached to the fourth carbon, so it is called 1,4-dimethylbenzene. Okay, so xylene has a hydrophobic nature, which allows them to accumulate in the lipid tissues of organisms. This hydrophobic nature also leads to poor solubility in water and causing them to bioaccumulate in aquatic organisms, which leads to long-term toxic effects. And xylene can also affect our central nervous system, which can cause respiratory issues.
Next, is this case related to parts per million? Yes, it is. But how? So basically, when the factories nearby the Kim River dump the chemical waste that actually contain benzene, xylene, or methane, this will lead to the release of toxic substances into the river. Thus, if the concentration of these pollutants exceeds the safe ppm limits, the water will become toxic, and this will cause harmful effects to the nature. But then, how do they measure parts per million in this case? So firstly, they will take water samples from different sides of the Kim River, and then they will measure the concentration of specific pollutants such as benzene. From here, they will see whether the water samples exceeds the safe ppm limits or not. Okay, for instance, the toxic threshold should be at 10 ppm, but then the actual result shows 50 ppm, which indicates severe pollution. Thus, immediate action must be taken.
So how does these chemicals actually seep into the soil? It all starts from toxic waste being discharged into the river. As polluted water flows, the soil on the riverbank will absorb these chemicals. Apart from that, the chemicals also seep deeper into the ground and pollute groundwater. Groundwater is actually an underground source that goes to wells and springs. So this causes the pollutants to be far away from the initial point of contamination. As the chemicals were absorbed into the soil, it can bring a huge impact on soil quality, crop yield, and also food safety. So, what are these chemicals and danger that it can bring that significantly impact the soil health? So, the first one is benzene. Benzene is very toxic to microorganisms as it can disrupt the cycle of other microorganisms. It can also contaminate groundwater as it contains hazardous carcinogen, and the remediation efforts are very lengthy and costly to remove it from the soil. The second one is methane. Methane can cause greenhouse gas emission and climate change as it reduces oxygen levels in the soil, thus affecting plant growth. And last but not least, xylene. It can infiltrate soil and groundwater and inhibit growth and germination. So now you can see how does these chemicals very significantly impact the soil quality, crop yield, and food safety.
So I would like to talk about the effects of the chemicals on humans. For methane can cause headache and nausea and vomiting. In severe cases, methane can changes in breathing and heart rate, asthma attacks, increases rates of preterm birth, and also numbness. Next, I'm going to talk about benzene. So basically, benzene can cause headache, drowsiness, dizziness, eye, skin, and respiratory tract irritation. At high levels, benzene can lead to anemia due to the bone marrow cannot produce the red blood cell. It can also cause unconsciousness and death. Lastly, xylene. Xylene can cause headache, dizziness, vertigo, and drowsiness. So, in severe cases, xylene can give damage to the liver and kidneys. It can also cause unconsciousness, heart failure, and death.
So next, I will be talking about states of matter of methane, benzene, and xylene. So firstly, methane is a gas. Why it is a gas? Because methane have weak intermolecular forces between its molecules. So methane molecules have a lot of kinetic energy and they move far apart. So since methane is a gas, it can easily escape into the atmosphere. So the implications of methane in industry is it diffuses quickly and can form an explosive mixture with air, which poses a significant fire hazard in industrial areas. Next, the state of matter of benzene is a liquid. This is because the flat ring shape of benzene allows these molecules to stick relatively close, making the dispersion forces strong enough to hold benzene molecules together as a liquid. So since benzene is in a liquid form, it can flow and spread easily, allowing it to move through cracks in soil or rocks reaching groundwater, then contaminate the water. Lastly, the state of matter of xylene is a liquid. This is because xylene has a structure of a benzene ring and two attached metal groups. The added metal group increases the surface area and polarizability, which strengthens the dispersion forces. So, the dispersion forces are strong enough to keep xylene molecules close together in a liquid form. So same like benzene, the liquid form of xylene also allows it to spread and persist in water. So when xylene is in contact with water, it does not break down easily and it can persist in contaminated water sources, which will cause a long-term pollution and health risks.
Since we know benzene and xylene were being flowed down the river, so the soil around them will also absorb those pollutants, which make the soil pH decrease since both of them are acidic in nature. Low soil pH will affect the breakdown of this pollutant because bacteria that degrade benzene and xylene work best at neutral to slightly alkaline pH. Therefore, acidic soil can slow down the biodegradation of these pollutants, causing them to persist longer and further harm the environment. So to solve this problem, we can treat the acidic soil by using calcium carbonate, which we can find in limestone or agricultural lime. When calcium carbonate react with the hydrogen ion in the soil, it will form calcium ion, water, and carbon dioxide. A reduction in hydrogen ion will lead to an increase in pH.